Today's heading is on properties of measures of averages. First, let us discuss on mean. Okay. I'll follow from single material. If necessary, I'll use the board. Yes, please join. First property, property number 1. Total of the values is the product. What do you mean by product? The operation multiplication. Sum means addition, product multiplication. Product means at least you need to have two things. So what you're going to multiply? One is size of the items and their mean. Okay. Size of the items is usually denoted by n, mean usually by x bar. So total of the values is summation x is equal to. Okay. So here I can write summation x is equal to n into x bar. Actually, when I write x bar, the formulae, it is summation x by n. So I cross multiply so that I get summation x is equal to n into x bar. Is it okay? For example, average salary is given. Okay, average salary is given in your organization, and the number of employees working in an organization is given. Yes, you can find the total salary by using summation x is equal to n into x. Also, when a wrong observation is given, okay, when a wrong observation is given, or else sometimes it happens, right, when you go for typing the captcha, you don't know whether it's 1 or L or capital I. Usually we get this confusion. Likewise, what happens is when we go for entering the numbers, sometimes it may be 63, we'll be reading in the reverse way. It will be 63 only, but when I dictate, it will look like 36 for me. Usually it happens. Likewise, 53, sometimes this 5 may be looking like 8 if I write in a fast manner. So instead of saying this as 53, I might be saying this as 83. Okay. Which means 53 is the right observation. I have entered a wrong observation. 63 is the right observation. I have entered this wrong observation. So what happens? I need to correct it. Because of one value has changed, what happened here is I got x bar by using the formula summation x by n. Because of one x value, this full summation now happens to be a wrong one. So I need to correct it. If I correct this numerator, okay, and if I enter the correct number of n, the correct n, then I'll get the correct x bar. Is it okay? So correct x bar is equal to correct summation x by correct n. We need to find correct summation x. How we find the correct summation x is wrong summation x minus you remove the wrong value, wrong observation, and you add the correct observation. Okay. Let me go for a problem. Actually, it is not there in single material. I just dictate the problem. I'll give the details, data. The mean, okay, the mean x bar for 40 observations is given to be 160. Okay. But when we go for the second checking, I found that instead of writing the number 63, I wrote it as 36. Instead of writing as 63, I wrote it as 36, which means which is the right one. This is the correct observation. This is the wrong observation. With having this 36 as the number, I got the x bar as 160, which means now I have to correct the wrong value. Which means I have to get the correct summation x. That is correct x bar. So to get correct x bar, I have to take correct summation x divided by correct n. What do you mean by this correct n? Sometimes what happens, 63, unknowingly, I might have written as 6,3. That also happens, right? Instead of writing 63 continuously, if I write 6,3, it will look like I'm entering two different values. That also is a wrong one. So I need to correct the correct value also. So now here in this problem, in my problem, n is equal to 40. So this value is nothing but the correct value 40. But what about this correct summation x is the wrong value. So I need to get the correct summation x where I take the wrong summation x. How we take the wrong summation x? Just now we have seen in the property. Summation x, yes, please join. Summation x is equal to n into x bar. What is n? 40. What is x bar? 160. What's the value? 6,400. Actually, I'm getting 6,400, but I have entered this wrong value. So let me remove 36 and let me feed the correct value, which is plus 63, which means minus wrong observation plus the correct observation. Yes, can I get the value for 427? Huh? So I got the correct value now. So what is correct x bar? Correct summation x by correct n, which is 6427 divided by 40. Can I get the value, please? 150. 160. Okay. Small difference only, but still it's the wrong one, right? So this is how I can use the property 1. If you want, you can make a note of it, please. What is property 2? I want to highlight this word. Please join here. If all the observations are seen by a variable of constant. Usually when we use the constant, we use the alphabet small k. Okay. Most of the situation. It's not like a rule, but it's understood in mathematics. If any one variable is unknown, we use it as x. Two variables unknown, x and y. Three variables unknown, x, y, z. Else x1, x2, x3. Okay. Usually we will not go for p, q, r, s, l, m, n. Okay. It's very rare. If you're not using x, y, z, we'll be using a, b, c. Okay. So likewise, n is meant for cardinal number. Count off. For frequency, we use it here. In set theory, it's cardinal number. Here, most of the cases for constant, we use it as k. So k for constant. C for constant or k for constant? You're not learning English alphabets. So it's k for constant. Okay. Then the arithmetic mean also will be k. See, let us consider this one. 2, 2, 2. You find arithmetic mean. 2 plus 2 plus 2. What do you mean by arithmetic mean? Add all and divide by 3. So 6 by 3, 2. See? Now read it. If all the observations assumed by a variable of constants, say k, say 2, then the arithmetic mean is also 2. So probably in your exam, how can you expect this question is if the observations assumed by a variable are all constants, say L. Then the arithmetic mean is also L. Instead of K, they are giving L means L. Instead of 2, they give it as 10 means 10. Okay. This is property number 2. Shall I go for property number 3? Property number 3. This is property number 3. Let me have it on the board. Please join here. Actually, we have two subdivisions. First one, the algebraic sum of a set of observation from the arithmetic mean is 0. Whenever you have like this type of statement, you have to go from the reverse order and please try to identify that one word. From there you have to take the equation like format. Is given to be is 0, which means something is equal to 0. Okay. What will be on the left hand side of the equation? We catch up with the word deviation. See, whenever you find this word deviation, whenever you find this word percentage, you have to check percentage on what? Deviation from where? Is given deviation from where? Arithmetic mean. So D is equal to, I am taking each and every value deviated from arithmetic mean. Usually the values are expressed as x. So x minus x bar will be the deviation. And what you have to do with the deviation? You have to take the algebraic sum. What do you mean by algebraic sum? You have to take as it is. Plus means plus, minus means minus. You know this absolute deviation? Modulus symbol. You will have like this modulus symbol. When you use this modulus symbol, because I don't want to have negative value, I want to have only positive value. For example, for distance from point A to point B, from city A to city B, you want to travel. How much is the distance? 500 kilometer. From B to A, you want to travel. You won't say this as minus 500. It's plus 500 only. Even though you go in a reverse direction, even the speed, even though you go downwards, you will not call it as negative. Okay, we have everything as in this terms as positive. So a modulus symbol will be used. This is what you call as absolute sum, absolute deviation. Here we are using algebraic sum, which means you just add it. So you take all the deviations and add it, which means summation d is equal to 0, or you can write it as summation x minus x bar is equal to 0. Okay, this is first one. Second one, the sum of the square of the deviation taken from the mean is always minimum compared to the deviations taken from any other assumed mean A. Please read it this way. Let me divide this into two paras, which means two lines. Is always minimum, which means what? I'm going to have less than symbol. See, in mathematics, is this equal to 0, equal to, or is this equal to, less than, or greater than, or less than or equal to, or greater than or equal to. It can be of any format. Okay. So here it's given minimum. So something is compared. One is compared with another. This is left hand side and this is right hand side. And left hand side is this one part which I have boxed. What is given here? Here also we are talking about deviation. Deviation from where you have to take? From mean. Okay, so which means x minus x bar, and you just go for the words before that, square and the sum, which means you have to square and then you have to sum it. So square it, okay, then sum it. If you do this way, then this happens to be what? Minimum, which means you have to compare with the right hand side. What is there on the right hand side? Compare to the deviations taken from any other assumed mean. Instead of taking the deviation from x bar, if you take some other value a, okay, which means you will be getting here as summation x minus a the whole square. Okay, this will be minimum, which means you have to have this symbol. Let me check this one. Let me take three values, 2, 3 and 4. I'm going to consider 4 cases. Okay, what are the 4 cases? What is actually x bar for this value? 2 plus 3 plus 4 divided by 3, or I have same deviation. That's why the middle value will be the average. So here it's going to be 3. Case 1. I'll take the deviation from x bar. Okay, case 2. Let me take the deviation from, let me divide the page first. Case 2. Let me take the deviation from x is equal, that is a, right? A I have taken. So a is equal to 2. Case 3. Let me take the deviation a is equal to this 3. See, this 3 and this 3 are different. You agree? This 3 is this different and this 3 is different. Why means here x is taking one value 3. Here x bar is 3. See, don't see as value. If you just see this as absolute values, it looks like 3 is equal to 3 now. No. I'm talking about the nature of 3. Here I am taking x as the value. Here I am taking this one as what? X bar as arithmetic. Okay. So here I take 3. Okay. Then case 4. Yeah, please. A is equal to 4. Can you just work out summation x minus x bar the whole square? Here summation x minus a the whole square for all the 4 cases. Yes, please. This is 2. Let me have different color. This is 2. This value? 5. This value? Yes, obviously 3 now, 2 now. Then this value? 5. See, now go for the second statement. It says the sum of the square of the deviation taken from x bar is always minimum. What is the x bar value? 3. See, in this case, it's 2. In the remaining case, 5, 2 and 2, which means always minimum. Either it will be strictly less than, or if it happens to be the same value, it will be equal. Okay. So how can I express this one? Summation x minus x bar the whole square will be less than or equal to summation x minus a the whole square. It is not strictly less than, it's less than or equal to, because it can have the same value 3 also. Apart from x bar, it can have the same value 3. In that case, it's going to be 2. Which means what? It has to be equal, right? So it can be less than or equal. Okay. So now let me go for next one. So you have to make a note of these two. This one and this one. Okay. Property number 3, actually there is property number 4. Actually I have to go for a complete detailed concept change of scale and origin. Probably I'm not going to discuss now, because I need like 1 hour for discussing this one alone. So I'm not going to discuss as of now. I'll take it in the next class. Okay. Next one. Property number 5. Combined arithmetic mean, which means two different means are given. Okay, mean 1 and mean 2. I need to combine them. So the heading itself says you're going to combine the arithmetic mean. Let us go for the illustration. Here are two groups, group 1 and group 2. Group 1 contains 5 elements with mean value what? How it is represented? X1 bar. Mean value 9. How group 2 is represented? With number of items 15 and X2 bar is 5. The combined mean can be taken as N1 X1 bar plus N2 X2 bar divided by N1 plus N2, and the notation used here is X12 bar. Sometimes the first group is containing girls, the second group is containing boys. Sometimes it might be represented as mean group with respect to girls and boys. Instead of X12 bar, it may be represented as XGB bar. Okay, so how we should, we can write it in any way. So let me substitute the values. What is N1? 5. X1 bar is X1 bar, right? So 5 into 9 plus 15 into 5 divided by, what's the total? 20. So I get the value as 6. Is it okay? This is the normal one. What happens here is we have to go for points to ponder. First case. Instead of 2 groups, if I have 5 groups, what you'll do? You'll just expand this. N1 X1 bar plus N2 X2 bar plus N3 X3 bar plus N4 X4 bar. If 10 groups, N10 X10 bar, the whole divided by all of the total. N1 plus N2, I have taken till 4, right? So N3 plus N4, total of all the items. That's point number 1. Second point, if sizes of the group are same, then the combined mean is the average of the group means. What do you mean by sizes of the group are same? Let me go for the board work. Sizes N1 and N2 are same. Let me take it as N itself. What's the formula for combined mean? This is the formula, right? X1 bar plus N2 X2 bar divided by N1 plus N2. Now instead of N1 and N2, I'm going to substitute the same value N. What happens here? Please join. N into X1 bar plus N into X2 bar divided by N plus N. Now take N common over here. So N into X1 bar plus X2 bar divided by 2N. Cancel the N values. So this is X1 bar plus X2 bar divided by 2. Please make a note. Shall I write this as average of, not combined mean, average of 2 separate means? Yes. So when we are using this, what do you mean by average? See, I'm giving 2 values, 2 and 3. How will you find the average? 2 plus 3 by 2. Now I'm giving 2 mean values. X1 bar is one mean value and X2 bar is another mean value. How can I find the average? X1 bar plus X2 bar divided by 2. See, I'm getting here. So 2 separate means are there. If I take the average, I'll get the X1 bar, the X12 bar value when N1 and N2 are same. This is second point. Okay, this is second point. Now third one, let me finish off, then I'll give some time to have a glance. Third one, if averages are same, okay, if averages are same, what do you mean by averages? Mean. Usually when they say the term average is represented for arithmetic mean. X1 bar, okay, X1 bar is equal to X2 bar is equal to same. Let me take it as X bar. Now substitute in the formula. Yes, please join. So formula is this one, right? You're coming along with me? Yes, tell me. Instead of X1 bar and X2 bar, substitute X bar. So this is N1 X bar plus N2 X bar divided by N1 plus N2. X bar seems to be common. So take out the X bar value. So this is N1 plus N2 divided by N1 plus N2. We can strike out the whole thing, which is nothing but X bar itself. So if you have 2 means and the 2 means are both same, then the 2 means is same as X12 bar itself, which means X1 bar is equal to X2 bar is equal to X12 bar itself. Need not worry about N. N can be any value. N can be any value. But if both these mean values are same, then it's nothing but the combined. So if a table is given saying that n1 different and n2 different, but x1 bar and x2 bar are same, then what is the combined mean? The same value of mean value. Yes, please go through. Kindly join with me. Geometric mean. First property, transformation in terms of log function. Yes, we have two formulas, right? What is the geometric mean formula? Nth root of product of all the values. Remember? Product of all the values. Nth root of. If you write in terms of logarithmic value of geometric mean is, or you can write it as, okay, in terms of log means, you can write it this as 1 by n summation log x. If you want geometric mean, then you can take geometric mean is equal to anti-log of 1 by n summation log x. Is it okay? Shall I write this 1 by n summation log x as summation log x by n? Yeah. See, the representation is different. This is nothing but logarithm of geometric mean. So, how can I define logarithm of geometric mean? Logarithm of geometric mean is nothing but arithmetic mean of log values. Am I right? For x1 you find log x1. For x2 you find log x2. For xn you find log xn. Add everything, which is summation, divide by n. So it can be taken as, so you can, if you want, you can make a note of it. So log of geometric mean is equal to average of logarithmic value of x. Yes, please make a note of it. Is it okay? If property 1 is okay, you can go for property 2. Any doubts, pa? So you have a doubt when the class will get over. Property 2. If all the observations assumed a variable of constant, say k, the nature of k should be here greater than 0. Why greater than 0? See, when we talk about geometric mean, we are talking about something multiplying and taking the root, right? You multiply all the values, okay, x1, x2, x3, xn, you multiply all the values and you take the nth root. If any value happens to be negative, what happens? For of minus something, so you will get it as in terms of I, complex number. So actually complex number is something related to imaginary number. You know why you got this notation I for this? You have natural numbers and imaginary numbers. Okay. All the positive values are natural numbers. But when we go for taking this way, there is nothing called as negative, but to denote the quotient, we are taking as negative. Okay. So I squared takes the value minus 1. So what is I? Root of minus 1. So whenever I get something negative inside the root, I have to express in terms of I. For example, I have minus 4. How can I represent this one? Minus 1 into root of 4. Am I right? So this minus 1 becomes I and this root 4 becomes 2. So the value is 2i. This is an imaginary number. Okay, this is an imaginary number. So to calculate geometric mean, all the values either should be, which means what? It should not be negative and it should not be 0 also. Because if it happens to be 0, inside the root you will get 0. You cannot find it. So it should be strictly positive values. So here, geometric mean, if all the observations are assumed by a variable of constant, say k greater than 0, then the geometric mean of the observation is also k. Example, 2, 2, 2. You take the geometric mean. You get it as 2. Property 3 and property 4. Property 3 and property 4. Let me go for the small working here. I'm going to take two set of values. One set represented by x. Okay. Another set represented by y. I take the geometric mean of x. I take the geometric mean of y. Okay. Apart from this, I multiply x and y value and I denote this as z is equal to x into y. What is the z new variable? X into y, which means what? I'm taking value of x, I'm taking value of y and multiply. If this is the value z, then geometric mean of z can be written as geometric mean of x into geometric mean of y. Okay. Likewise, and if I'm trying to write z is equal to x by y, which is in the ratio form, we'll not call this as division. See, for multiplication, we are calling this product. Likewise, for division, we'll not call it as division is an operation name. See, this is a symbol for division. Okay, but we'll mention this as ratio. This is a symbol for multiplication, but we mention it as product. This is a symbol for addition, but we mention it as sum. This is a symbol for, we mentioned it as difference. Okay, so here it's a division, which is x divided by y, but how we mention this as ratio of x and y, x to y. So here geometric mean of z will be geometric mean of x divided by geometric mean of y. This is very, very important. Recent times they are asking this two sets. This is property number 3 and this is property number 4. Yes, you can find one example in Singer material where you have x containing 3 values 3, 6 and 12. Y containing 3 values 1, 2 and 4. So we are taking z. How we are taking z? X into y. Okay. We are taking another z, which is x by y format. Then these both will be satisfied. Yes, please check whether this is okay. Could you find how you got this? Yeah. I have taken such a way. It can be any observation. See, I want a calculation to be easy because you'll be worried how to take the cubic root. Then obviously Santosh will say a trick. Okay. Immediately his class will get highlighted. என் class விட்டுருவீங்க. Okay. I don't want to focus on calculation. I want to focus on concept. That's why I have taken such an easy number so that you have to easily get the value of geometric mean. Is this okay? So I think geometric mean property only 4 we have. Shall I go for harmonic mean? Harmonic mean? Yes, please join. Harmonic mean is the reciprocal of arithmetic mean of reciprocal observation. Please highlight. So this is the definition, right? If there is x, what I do? I take 1 by x. If it is 2, what I do? What I take? 1 by 2. 3, 1 by 3. Which means I take the reciprocal observation. And not only that, the formula also is reciprocated. So you'll get two words of reciprocation. One is reciprocating the arithmetic mean formulae. Another is reciprocating the observation itself. We have to be very careful. Okay. Property number 2. If all the observations taken by a variable of constant, say k, then the harmonic mean is also constant. Shall I go for property number 3? Property number 3 is a direct one, combined harmonic mean. As we did with combined arithmetic mean, the same way it's done over here. So what's the normal harmonic mean formula? N by summation 1 by x. Here we'll take n1 plus n2. If you have two sets, n1 plus n2 divided by n1 divided 1 divided by x1 bar plus n2 divided by x2 bar. This is combined harmonic mean. Okay. I was discussing this egg problem. You remember? I bought 5 eggs for 20 rupees. In another shop, I bought another 5 eggs for 22 rupees. Then I go for finding the combined harmonic mean, which means what is the average price of one egg. You cannot directly say it's 20 by 5 here and it's 22 by 5. You cannot do this. Here you have to find because you are making some comparison per egg. Price per egg you are finding. See, when we use harmonic mean per, example we did with speed calculation, right? For speed, how we find the speed? It is 4 kilometers per hour, which means we have to take in terms of distance by time. Likewise, to find the egg price, what we do? Price of egg, which means rupees per egg, per piece. Okay, it's Indian rupees per piece. You go and buy egg in America, dollars per piece. Okay, so whatever it is. So here I'm buying two sets of eggs. One is what? How much? 20 rupees. Which means one set of eggs is 5 eggs containing 20 rupees. In another shop, the same 5 number of eggs, but what happens? 22 rupees. Here I have to use not arithmetic mean, instead harmonic. Okay, so this is property number 3. Please make a note of this. Harmonic mean is most suitable average when you desire to give greater weight to smaller numbers and less weight to larger numbers. Okay, so because you are reciprocating, right? If I talk about the value 100, when you use harmonic mean, it becomes 1 by 100. When you talk about 3, it becomes 1 by 3. What are the commodities you have in your hand? Which means your home. You know, you have rice, you have wheat, you have sugar, you have gold. Let me go for sugar and gold. Sugar, how many kgs you have? 5 kg sugar. Ration 5 kg nu. Okay. Gold, how much you have? Kg. 100 grams. Obviously, instead of having 100 grams, let me have it and same units. 1 kg. Okay, tell me. 5 kg sugar irukka, 1 kg gold irukka. 1 kg gold irukku. See, which means this 1 kg is, if you go for the value wise, not the weight wise. Value wise, you have to write it as 1 by 1. Here, it's 1 by 5. That's why we give importance for harmonic. Is it okay? Shall I go for the next content? This we have already done. Comparison of 3 means. Arithmetic mean will be greater than or equal to. Geometric mean greater than or equal to harmonic mean. Is it okay? This one we have done? I don't think so. This one we have not done. I don't know. Check the first problem. Individual observation. We did this problem, right? 3, 6, 24 and 48. What does arithmetic mean? Yeah, get me the value. From your material. From your material. Where is that page? That's the very first problem. See here, this problem. What does arithmetic mean? 20.25. Page 2.4. What does geometric mean we got? See, we have worked out this problem normally. 12. What does harmonic mean? 7.11. What's the relation between the three means? G square is equal to A into H. What is A value? 20.25. A is arithmetic mean into H value 7.11. If you multiply this, you'll get 144. 12 square. Check whether you're getting it. You'll not exactly get 144 because I have 20.25. Usually we have to round off to 4 decimals and it's not 7.11. We have to round off to 4 decimals. So obviously you get somewhat closer to 140. Okay? Okay. So shall I write this one as, instead of writing like this, shall I write as G is equal to root of A into H? See, when we have 4, if you take square root, it becomes plus or minus 2, right? So here, when you take square root, you cannot have plus or minus. Because geometric mean will never be negative. Because for negative value, you cannot take geometric mean. It's not applicable. It will be plus only. Okay. Then what is for? This one all done. Third one. I have two values, x and y. What does arithmetic mean? Simple. X plus y by 2. Right? This one over. What does geometric mean? Root of, square root of. If nothing is mentioned, no number is mentioned, is understood as square root. X into y. Over. Harmonic mean. Into. Correction for. Into. Harmonic mean. 2 divided by 1 by x plus 1 by y. See, you substitute in the formula, you get 2 divided by 1 by x plus 1 by y. You take LCM. 2, this one, butterfly method. Y plus x divided by xy. You take this xy to the numerator. So this happens to be 2xy divided by x plus y. This is often repeated question for both CA and CM. Often repeated. So you please make a note of it. Okay. That's about mean over. Median and mode. Shall I take over? Only a few content I have. Shall I do it? Median. Property 1. This content is related with change of origin and scale. Probably I'll deal that in the next class. This is a separate concept, so I'm not dealing now. Property 2. For a set of observation, the sum of absolute deviation is minimum when the deviations are taken from the median. Is minimum. So I'm going to have this symbol. When the deviations are taken from the median, which means absolute deviation. So sum of all the absolute deviations, where is the deviation taken from? Median will be minimum compared to any other value. It can be any value. So we are going to consider these three values. Can you help me out? We'll work out this problem. What are the three values? 0.5. What's the value? 3 and 4. Huh? 3 and 4. Okay. What is the median for this? How you find the median? The center value is the median. 3. Okay. What's the property here? What is the property here? I have to check with summation modulus value, not normal brackets. Normal brackets means algebraic sum. Here, absolute deviation. So, which means I have to take modulus value, x minus median. I have to take square here. No square, nothing is mentioned. Square is mentioned over there for mean. Here, median, no square is mentioned. Okay, let me substitute. Tell me, 0.5 minus 3, absolute value. You should not forget this one. Next, 3 minus 3. Okay, next, 4 minus 3. Sorry, 4 minus 3. Yes, value. 0.5 minus 3. Minus 2.5. I need to remove the absolute deviation. So this is positive 2.5. Is it okay, clear? 3 minus 3. 0. 4 minus 3. It's positive 1. So directly take it as positive 1. So what's the value? 3.5. What the property says? This will be minimum, which means to check whether this value is minimum or what, I have to compare with some other value. So what I'm going to do here is, let me do the working for the same thing. Let me do the working as summation x minus mean value. Let us check. I need to find the mean value. What is mean? 0.5 plus 3 plus 4 divided by 3. Value for 2.5. Okay. Let us substitute. Yeah, tell. 0.5 minus 2.5. Absolute value. Okay. 0, 3 here. 3 minus 2.5 plus 4 minus 2.5. You understand how you are getting this line? You are not doing anything, just x minus x bar. So what is this value? It's minus 2. Obviously, you are removing the sign. So this is 2. This is 0.5 positive only. And this is 1.5 positive. Definitely, this value is not going to be 3.5. More than that. How much? 2.5, 4. So this value is minimum when the deviations are taken from median. Okay. Please check whether it's okay. You need not write it down because it's there in the single material. So just see, if you have any doubts, we'll discuss. Is it okay? So this is property number 2. Comparison, quite important. When we have that or the positional average in the line, the data line, if this is the full set of data, the middle position will be denoting the median value This one will be quarter 1. This one will be quartile 3. Okay. This is denoting the position and the value of that is quartile. Okay. And if you check the position values along with the size, you will find that mean all the values will consider average. All the values will consider. Only for median, it will be the middle one. When you go for symmetric distribution, probably you might have learned this one. Symmetrical curve, bell-shaped curve. In this case, mean, median, mode, everything will be same. Only this happens only in the case of symmetrical distribution, but not in all of the cases. Okay. So here, that will do in another topic. We have that in our syllabus, don't worry. Everything we have. Okay. So how it is being compared? See, if I place a line, I say number 1 is here, number 2 is here. How you write it? 1 is less than 2. Likewise, here quartile 1 will be less than median, will be less than quartile 3. But if you have a keen note, if you check here, it's written as less than or equal to, right? If all the values happen to be same, 2, 2, 2, what is median? 2. What is quartile? 2. So in that case, you have to write it as equal to. So it will be less than or equal to, less than or equal to. The same thing you can work it for deciles also. This is median, or you can write this as D5. Am I right? This is quartile 3, or you can write it as D7.5. Shall I write as median is less than or equal to D7.5? Yes, I can write it. Please tell me, quartile 2 is less than or greater than D2. Which one holds good? So not Q2, sorry. Q1, sorry. Which symbol? Q1 means quartile 1. This symbol or this symbol? First symbol. How you say? No, it cannot say equal. Not in all the situations. Okay. When you draw the line, what is D2? Okay. What is decile? The whole 10 parts. When you divide for 4, which means for quarters, 10 divided by 4, 2.5. What is quartile 1? 2.5. So quartile 1 will be here and D2 will be very closer but smaller. Because D2.5 only is quartile 1. No. D2 is less than or equal to Q1. See, you should not check 2 is bigger or 1 is bigger. D2 is less than quartile 1. Okay. So this one, okay. Huh? Able to manage this one? No. Okay. I have a line. Tell me, 1 is bigger or 2 is bigger? 2 is bigger. How you write it in mathematical lines? 1 less than 2. Okay. Now I'm saying that this is quartile 2. This is decile 2. Which means what? D2 is less than Q2. But I don't know the value, right? What is D2? The whole 10 parts. Among that, I'm taking 2 parts alone. What is D2? Second decile. I'm taking 2 parts alone. Okay, which means 10 divided by 2. Sorry, 10 divided by 5. The n divided by 10. What about quartile? Quartile means full 4 parts. In that, I'm taking 1 part alone. So, the n divided by 4. This will be 1. Okay, here it will be, in this line, this is my median. This is my quartile 1. This is my quartile 3. Quartile 1 means 25%. Decile 2 means 20%. Okay. 1 part is 10%. 2 part means 20%. So here I'll be having the relation D2 less than or equal to Q2. You just chew this concept, else I'll help you out. Okay. Shall I take over? Also, we can write the second one. Median is equal to Q1 plus Q3 by 2 pi. That's about median. Mode, there is only one property. Again, this is related to change of origin and scale. I'll discuss this in the next class. So that's all about measures of averages. The properties related to measures of averages. Correct. D2.5 will be equal because when you divide the whole into 10, there is into divide by 10, I'll get 1 part. So if you take 2.5 parts means it will be 25%. Okay, 25% means it matches with Q1. So it will be exactly equal. Okay. Yeah. So that's about measures of averages. Pa. So change of